In the world of construction, ambition often walks hand in hand with doubt. Throughout history, some of the most transformative infrastructure projects were dismissed as impossible, too expensive, or destined for catastrophic failure. Engineers were called dreamers. Governments were accused of wasting billions. The world watched, waiting for collapse. History is littered with the wreckage of failed megaprojects, billions of dollars buried in concrete that crumbled, ambitious visions abandoned halfway to completion, reputations destroyed by projects that promised everything and delivered nothing. But sometimes, against all odds, the impossible becomes reality. Today, we're exploring 3 megaprojects that defied every prediction, overcame seemingly insurmountable odds, and changed the world forever. These are the construction projects everyone thought would fail. Our first story takes us to one of the most strategic waterways on Earth, the Panama Canal. A thin ribbon of water connecting 2 oceans, holding the power to make or break global economies. When the original canal opened in 1914, it was hailed as one of the greatest engineering achievements in human history. Ships that once spent months navigating around South America's treacherous Cape Horn could now cross between the Atlantic and Pacific in just hours. For nearly a century, it served as the critical artery of international commerce. But by the early 2000s, the canal faced an existential crisis. The shipping industry had undergone a revolution. Container ships had grown into floating cities of steel. These post-Panamax ships, stretching over 366 meters in length, carried up to 3 times the cargo of older vessels, and they couldn't fit through the Panama Canal. The century-old locks had become a bottleneck strangling global trade. Major shipping companies were forced to choose, use smaller ships or bypass Panama entirely, adding days and millions of dollars to each voyage. The canal that had once defined modern shipping was becoming obsolete. In 2007, after a national referendum where 78% of Panamanians voted yes, the government announced an audacious plan: expand the canal with entirely new locks for $5.2 billion, nearly 40% of Panama's entire GDP. Skeptics were everywhere, and they had history on their side. Critics pointed to the original canal's construction, a nightmare that claimed over 25,000 lives from disease and accidents. They reminded everyone that the French company that first attempted it had gone bankrupt. Ferdinand de Lesseps, who had successfully built the Suez Canal, had been humiliated by Panama's geography and climate. The doubters warned of geological instability, unpredictable weather, and the logistical nightmare of expanding a working canal that handled 14,000 ships per year and couldn't shut down for even a single day. The project faced immediate challenges that tested the limits of modern engineering. The new locks required excavating 150 million cubic meters of earth, enough to fill 60,000 Olympic swimming pools. Engineers had to work mere meters from live shipping traffic, where one miscalculation could disrupt 6% of global maritime trade. The technical demands were staggering. Each lock would be 427 meters long, 55 meters wide, and 18 meters deep. The lock gates themselves were engineering marvels, rolling steel structures 7 stories tall, weighing up to 4,200 tons each. Moving these behemoths into place with millimeter precision while water flowed around them seemed impossible. Then came the problems no one anticipated. In 2014, a bitter dispute erupted. The construction consortium claimed unforeseen geological conditions and demanded an additional $1.6 billion. Work ground to a halt. Ships continued through the old canal while the expansion sat frozen, half-finished, bleeding money. Cost overruns ballooned. Deadlines slipped month after month. International media declared the project a debacle. The critics smugly declared they had been right all along. Water supply emerged as another crisis. Panama's rainy season is intense but short. Engineers discovered that during dry seasons, water levels in Gatun Lake might drop too low to operate the new locks. Running out of water would be catastrophic. But the engineers refused to give up. They innovated. They developed an ingenious 3-basin water-saving system for each lock chamber. Instead of draining water into the ocean, the system captured and recycled 60% of it. Water would flow into holding basins, then be reused for the next ship. This single innovation reduced water consumption by millions of gallons per transit. They implemented real-time monitoring systems using thousands of sensors embedded in the concrete, tracking every millimeter of structural movement, every fluctuation in pressure. Computer algorithms analyzed data 24 hours a day, predicting problems before they became catastrophic. The workforce, 40,000 strong at peak, worked through conditions that would have broken lesser projects. They endured torrential rains that transformed sites into lakes. They battled 95-degree heat with suffocating humidity. They worked night shifts under floodlights, racing against deadlines and budgets and the weight of a nation's expectations. If you're fascinated by these incredible feats of human engineering and want to dive deeper into the stories that shaped our modern world, make sure you're subscribed to this channel. We're constantly uncovering the hidden narratives behind the structures you see every day. Hit that like button if you're enjoying this journey, and stick around because our next two stories get even more unbelievable, involving battles against the ocean itself and a railway project that spanned an entire subcontinent. Now, back to Panama and the final push to prove the doubters wrong. The financial dispute was resolved through complex negotiations. Work resumed, but the pressure was immense. Every day of delay cost millions. Every setback was amplified by media hungry for failure. Finally, after 9 years of construction, countless setbacks, and billions spent, the moment of truth arrived. On June 26, 2016, under a cloudless sky, watched by thousands of spectators and millions on television, a massive Chinese container ship named the COSCO Shipping Panama approached the new Agua Clara locks. The vessel measured 299 meters long and carried 9,472 containers, more cargo than 3 traditional Panamax ships combined. The world held its breath as the ship entered the first chamber. Water surged into the basins with controlled precision. The massive gates swung open and closed like clockwork. Hydraulic systems hummed. Computer monitors displayed thousands of data points confirming what everyone could see. It worked flawlessly. The COSCO Shipping Panama completed its transit in just over 8 hours. The project that everyone said would fail had succeeded spectacularly. Today, the expanded canal handles ships carrying 14,000 containers, nearly triple the previous capacity. It processes over 450 million tons of cargo annually, generating $2.5 billion for Panama's economy each year. The engineering innovations have been adopted by infrastructure projects worldwide. The doubters were spectacularly wrong. Our second story takes us to a country that has been fighting the ocean for centuries, the Netherlands. The Dutch have a saying, "God created the world, but the Dutch created the Netherlands." Nearly a third of the Netherlands sits below sea level. Without constant intervention, much of the country would be underwater, reclaimed by the North Sea. For 1,000 years, the Dutch built dikes, drained lakes, and pushed back the ocean meter by meter. They became the world's experts in water management and hydraulic engineering. But expertise couldn't prepare them for what happened on February 1st, 1953. That night, a catastrophic combination of events converged. A powerful North Sea storm, with winds exceeding 140 kilometers per hour, aligned with a spring tide. Storm surges rose to unprecedented heights. The moon, in its closest approach to Earth, amplified the tide's power. The result was apocalyptic. Storm surges breached Dutch coastal defenses in over 150 locations. Water poured through like liquid thunder, flooding over 160,000 hectares. Entire towns vanished beneath the waves. Families were awakened by freezing seawater rushing through their doors. When the waters receded, the toll was devastating. 1,836 people had drowned. Over 72,000 were displaced. 200,000 hectares of farmland were contaminated with saltwater. The economic damage exceeded 1 billion guilders. The nation was traumatized, but from tragedy came resolution. This would never happen again. Weeks after the flood, the Dutch government established the Delta Commission with an impossible mandate: design a system that could protect the Netherlands from a storm that might occur only once every 10,000 years. Not once per century, not per millennium, once every 10,000 years. The result was the Delta Works, one of the most ambitious engineering programs ever conceived. The plan called for closing off the vulnerable Delta region by constructing a network of dams, barriers, and storm surge defenses across multiple sea inlets. Engineers would seal over 700 kilometers of coastline. The scope was breathtaking. The timeline measured in decades. The cost would run into billions. The international engineering community was deeply skeptical. Critics argued it was economically unfeasible. The Netherlands was recovering from World War II. Committing billions to a half-century project seemed like madness when schools needed rebuilding. The centerpiece was the Oosterscheldekering, the Eastern Scheldt storm surge barrier. And this is where critics predicted total failure. The Eastern Scheldt was a massive estuary, 9 kilometers wide, with powerful tidal currents. The seabed dropped to 30 meters of unstable sand and clay. Building anything permanent seemed impossible. Then environmental groups intervened. Marine biologists warned that closing the estuary would be an ecological catastrophe. The tidal flats fed millions of migratory birds. Oyster and mussel fisheries supported entire communities, generating tens of millions annually. Protests erupted. Fishermen blockaded sites. In 1976, the Dutch government made a decision that seemed to doom the project: abandon the solid dam design. Instead, build a flexible barrier with gates that normally remain open. The gates would only close during dangerous storms. Engineering experts were stunned. A flexible barrier across 9 kilometers of violent ocean had never been done at this scale. The new design required 65 massive concrete pillars on the seabed, each 40 meters high. Between them would hang 62 steel gates. The pillars alone weighed 18,000 tons each. Positioning them on unstable seabed with powerful currents seemed impossible. The Dutch engineers developed a revolutionary foundation system. They laid a bed of sand and gravel on the seabed, requiring 12 million cubic meters of material. On this, they would lower the massive pillars. The solution was the Ostrea, a specialized crane ship that could lift 18,000 tons and position pillars to within millimeters, even in rough seas. Each installation was a multi-million-dollar gamble. If the pillars settled unevenly, the entire structure could be compromised. Construction crews worked in brutal conditions: North Sea winter storms with 10-meter waves, freezing temperatures. Work proceeded only during brief weather windows. Sometimes crews waited weeks for calm enough conditions to lower a single pillar. Progress measured in years, budgets ballooned. Critics declared it a monument to government waste. Then, on October 4th, 1986, after 33 years of construction, Queen Beatrix officially opened the Oosterscheldekering. The American Society of Civil Engineers declared it one of the 7 wonders of the modern world. The barrier's 62 steel gates can close in 75 minutes when surges threaten. Computer systems monitor conditions 24 hours a day, predicting dangerous weather days in advance. Since completion, the barrier has closed 29 times, each time protecting millions of people and billions of euros in infrastructure. But the most remarkable vindication came from the environment itself. The ecosystem didn't just survive, it thrived. Fish populations rebounded, bird migrations continued. The fisheries now generate over 100 million euros annually. The Delta Works became a blueprint for coastal protection worldwide. After Hurricane Katrina, American engineers traveled to the Netherlands to learn. The project critics declared impossible became one of the most successful infrastructure programs in history. Our final story takes us to India, a nation of 1.4 billion people, where the railway system was both lifeline and bottleneck. India's love affair with railways began in 1853. By independence in 1947, India had the 4th largest railway network in the world. Railways became the nation's circulatory system, but by the early 2000s, the system was choking. Passenger and freight trains shared tracks, creating catastrophic congestion. Priority went to passenger trains, meaning freight trains spent days sitting on sidings. The statistics were damning. Freight trains moved at 25 kilometers per hour. A shipment from Mumbai to Delhi could take over a week. For comparison, Chinese freight trains averaged 60 kilometers per hour. In the United States, 70. India's crawling speeds destroyed competitiveness and strangled growth. Industries suffered enormously. Manufacturing companies couldn't rely on timely delivery. Coal arrived so late, power stations ran out, triggering blackouts. Agricultural products spoiled. Small businesses couldn't compete because shipping costs consumed profit margins. Inefficient freight transport cost the economy over $40 billion annually. India's global competitiveness eroded. In 2006, the government announced an unprecedented solution: build dedicated freight corridors spanning thousands of kilometers. 2 massive corridors totaling over 3,300 kilometers. The cost, $20 billion. Analysts were dismissive. India's infrastructure projects had notorious reputations for delays and overruns. The freight corridors would span multiple states with different governments. Acquiring land from thousands of farmers seemed impossible. The technical requirements were daunting. The corridors needed to accommodate double-stacked containers on trains at 100 kilometers per hour, something India had never done. Skeptics predicted 30 years, if completed at all. Challenges proved skeptics right immediately. Land acquisition protests erupted. Farmers blockaded sites. Legal battles were endless. Environmental clearances delayed. Funding faced bureaucratic obstacles. Construction presented nightmares. Elevated viaducts spanning dozens of kilometers. The Western Corridor required 36 major bridges and 152 minor bridges. Monsoons turned sites into lakes. Workers faced 115-degree heat. Equipment broke constantly. Corruption added difficulty. Skeptics declared victory. India can't execute projects of this scale. But slowly, the corridors took shape. Engineers used cutting-edge concrete slab tracks. They electrified sections with overhead lines, creating one of the greenest freight systems. Computer-controlled signaling allowed higher speeds. In 2018, breakthrough arrived. The first section became operational. The first freight train completed a 7-day journey in 48 hours. The transformation was dramatic. Industries reported 40% logistics cost drops. By 2024, major portions moved over 300 million tons annually. Manufacturing hubs sprung up. Small businesses ship overnight. Perishable goods reach cities fresh. Passenger trains run faster. International companies expand. Manufacturing experiences renaissance. The bureaucratic fantasy became the most successful infrastructure project in modern Indian history. 3 projects, 3 continents, 3 impossible dreams that became reality. Panama proved a century-old infrastructure could be revolutionized. The Netherlands proved humanity could hold back the ocean while protecting ecosystems. India proved nations with bureaucratic reputations can execute transformative megaprojects. What united them was persistence against overwhelming doubt, refusal to accept impossible, understanding that the greatest achievements often begin with, "It can't be done." These projects changed the world. They created blueprints future engineers will follow. They reminded us that expertise matters, that people who spend decades studying engineering might know what they're talking about. The next time you hear ambitious projects dismissed as too expensive, too complex, too risky, remember these stories. Remember the Panama Canal expansion experts said would bankrupt Panama. Remember the Delta Works critics called impossible. Remember the Indian freight corridor analysts predicted would never complete. Remember that projects everyone thought would fail are often the ones that change the world. Because history has shown us that humanity's greatest achievements are built on the rubble of other people's doubts. Thanks for watching. Check out our video on mega projects that actually failed. Subscribe for more documentaries about the structures, systems, and stories that built our modern world. Until next time, keep looking up at what humanity can achieve when we refuse to accept the impossible.